Hello, this is Mr. Agbamu Idanagwene. In today's video, I want to show you how you can differentiate trigonometric function. And that is our topic for today, differentiation of trigonometric function. And what I want to achieve today, I want to show you how you can differentiate the 6 basic trigonometric functions. So this is summaries of the 6 basic trigonometric functions. You can see sine x, dy dx. When you differentiate sine x, which is dy dx, is going to give you cos x. When you differentiate cos x, dy dx is going to give you minus sine x. And when you differentiate tan x, it's going to give you sec square x. Then when you differentiate sec x, it's going to give you sec x tan x. Then differentiation of cot x is going to give you minus cosec square x. Then when you differentiate cosec x, is going to give you minus cosec x cot x. So this is summary of the differentiation, but all I want to show you today, I will use first principle to show you how this table came about. How did we differentiate sine x to give us cos x? So let's start. Let me show you how we go about it. So if you could recall from first principle, how we differentiate from first principle, you will see that when I have my function, let's say y equals to sine x, so this is my function y equals to sine x. If I'm to differentiate this from first principle, that means I'm going to add delta y to both left and right, delta y to the left side and delta x to the right hand side. That is something like this. So I'm going to have y plus, I need a capital letter, so y plus delta y will now be equals to sine, need to put it in brackets, x plus delta x. So this is the first sign from your first principle of differentiation. Hope you have not forgotten it. You add delta y to y, you add delta x to x. Then the next thing you need to do now is you need to make delta y the subject by taking y to the other side of the equation. So I'm going to have delta y is equals to sine x plus delta x, then minus y. So that is it. And what is the value of y? In the equation we are differentiating y equal to sine x, so we need to substitute y as sine x in this equation, that you are going to get something like this. So if I copy it fast, you're going to get something like this. Then you remove y and replace it with sine x. So that is the first thing you do. Then what next? So if you look at this, you will see that there's nothing we can do next now. The next thing to do is to divide both sides by delta x, so that we can have delta y delta x. So now divide both sides by delta x. I'm going to have delta y divided by delta x, which is now going to be equals to sine x plus delta x minus sine x, then divided by delta x. Now at this stage we are in the standstill situation, so we don't have any other thing to do now. We cannot rationalize the numerator, or else we will not get any result. The only thing that can help us now to move further is to have a good knowledge of trigonometric identities. We need to know what is trigonometric identity. So I'm going to go through a review of trigonometric identity. All I want you to do, just get your pen and your paper, you can write them out so that you can get them. Though this topic is not in our topic of today is not to show you how you can get the trigonometric function, but I just want you to know them so that when you meet them in differentiation or in integration, you can know what to do. So let me just summarize them using this GeoGebra applet I have here. So you know our trigonometry, this is sine, cosine, tan. What I have here is angle 45. So if you draw your trig, you can see the triangle AB and O. So this is the triangle ABO. Then you can get your sine 45. You can see the result for sine 45, 0.7071. Then you can see cos 45, 0.7071. So they are equal. Sine 45 and cos 45, they are equal. If I want to see my result in fractional form, you can see it, which is square root 2 over 2 for cos 45 and square root 2 over 2 for sine 45. So, but this is not what I want to show you now. What I want to show you is this. The identities, they are very important. The first identity you need to learn is this. So you can get your pen and write them out. First identity, which is sine theta, opposite over hypotenuse. This is basic trigonometry. You should know this one very well. Opposite over hypotenuse. Then for cos theta is adjacent over hypotenuse. You can see it. Then tan theta is opposite over adjacent. Then for cosec, you can see cosec. Cosec is now the reverse now, which is 1 over sec. That is hypotenuse over opposite. That is 1 over sine, sorry. 1 over sine is the same thing as sec, cosec. So take note of that. Then sec is hypotenuse over adjacent, which is 1 over cos. Then tan is 1 over tan will give you cot. That is cot is adjacent over opposite. So just get your pen and write all these out. They are very important. So these are the 6 basic trigonometric ratio. Get it in the right angle triangle form. So this is how it will look like in the right angle triangle. So if I draw my right angle triangle, you can see it A, B, and C. The opposite is AB, hypotenuse is OB. So that is opposite over hypotenuse, AB over OB. So you can sketch this triangle out, bring out your 6 basic ratios. So it's very, very important. Take note of this. So this is the first identity I want you to take note of. The second identity I want you to learn is this. So cot theta is the same thing as 1 over tan theta. Take note of this. 1 over tan theta is very, very important. Then sec theta is 1 over cos theta. Take note of this. Very, very important. Because most times when you want to differentiate sec theta or cot theta, you need 1 over tan, you need 1 over cos. Then cosec, this is cosec theta. When you want to differentiate this, you need to substitute it with 1 over sine. That is why that table I summarized initially, you need to memorize that table. When you know this differentiation, most times you don't need to even use first principle to differentiate them. Just go straight and use them and get your result very fast. But for learning purpose, you need to know how they came about so that you don't just feel that we forge those differentiation. So this is the second identity I want you to take note of, which is reciprocal identity. The third one I want you to take note of is this, which is tan. I told you before, tan is the same thing as 1 over cot, which is the same thing as sine over cos. So whenever you have tan theta, just do sine of the angle divided by cos of the angle. It's still the same thing. So when I want to differentiate tan theta, now this is what I will use to differentiate tan theta. Sine x over cos x. So this is what I will use to show the differentiation. Take note of that. Then for cot theta, you have cos theta over sine theta. Take note for cot theta is cos theta over sine theta. Take note of that, which is very, very important. So just summarize all this down. This is just a proof to show that they are correct. This is just a proof. So there's nothing special about that. So if tan theta is equals to 1, how did you get 1? When we use 45 as an example, so sine 45 divided by cos 45, since they are equal, it will give you 1. Take note of that. The same thing with cot 45, it will give you 1, since it's the ratio of the same number. So you can write this down also, very important. Then the fourth ratio I want you to take note, which is identity. The fourth identity is this. This is another very important trig identity you must not forget. That is sine square theta plus cos square theta is equals to 1. Take note of this. Then this is just a proof to show that this ratio is correct, that this identity is correct. Put 45 here, put 45 here, sub down, you will see that it will give you 1. Then when you divide by tan, when you divide by cos theta, you divide each of these terms by cos theta. So cos, sine divided by cos will give you tan. So you can see tan square theta plus 1 is equals to sec square theta. We know 1 over cos is the same thing as sec square theta. So take note, 1 over cos is the same thing as sec, which is gotten from the second identity. You can see it. 1 over cos is the same thing as sec theta. So that is number 4. Then when you divide by sine also, you are going to get 1 plus cot square theta equals to cosec square theta. So take note of this. You can write them out. Just pause the video, go through them, write them out, put headings so that you can get it step by step. Then the number 5 identity is negative angle identity. Take note of this. So when you have a negative sine angle, that is sine minus theta, you are going to have a negative answer, minus sine. You can see an example is given here. When you take 45, for example, sine 45 is 0.7071. Then when you find the negative of this, you are going to have a negative result like this. Take note of that. But if it's cos, you are going to have a positive result. For tan, you are going to have a negative result. For cosec, you are going to have a negative result. For sec, you are going to have a positive result. Then for cot, you are going to have a negative result. Please take your pen, write this down, and learn it. They are very, very important. The number 6 ratio is the compound angles, which is sum and differences. When you have cos A plus B, it will give you this. Take note, cos A plus B is equal to cos A cos B minus sin A sin B. Then for negative, it will give you the positive result. Take note of this. Then for sine, when you sum sine A plus B, this is what it will give you. Just get your pen and write them out step by step. Then you can learn it as time goes on. You'll be used to it. You can use them especially when you want to differentiate or when you want to learn the topic trigonometric identities. Then for tangents, which is tan, you can see the sum, you can see what it gave. Then the difference, you can see what it gave. So take note of this. Then number 7, we are talking of the complementary angles. So take note of this also. Cos 90 minus theta is equal to sin theta. So this is for complementary angles. So just take note of this. Though this is the proof, it's just trying to demonstrate it here to see what you are going to get. Then number 8, which is very important also. This is a double half identity. So take note of this. Cos 2 theta, there are 3. Cos 2 theta have 3 identities we give to you. This is the first, the second, the third. Just write them out on your paper and study them carefully. Then this is sin 2 theta, then tan 2 theta. Take note of this. Then number 9 is the product to sum identity. Take note of this also. They are all very, very important. Then number 10 is what we are going to use in our next step. So this is what we are going to use in our next step of our differentiation. We say sin A plus sin B. You see the result it gave 2 sin A plus B over 2. Then just add the 2 results here, A plus B. Then if it's for negative, you take 2 cos A plus B over 2 sin A minus B over 2. So that is that. Then the last identity is half angle identity. So take note of all this. So as you write this through, pause the video for each identity. Make sure you write it out. Then as time goes on, you'll be used to it. Just keep studying it gradually, especially when you are learning the topic trigonometric identity. You need all these identities. They will help you when solving your question, and you also need them in differentiation. So this is number 10 is what we are going to use in our next step. So let's go to the differentiation we were doing before. So this is where we are now. So how do we continue? As I said, rationalization cannot work here. So how do we move on so that we can get our answer for differentiation of sin x, which is equals to cos x? How do we do that? we need to use this identity, which is this. So this is sine A minus sine B. So what does it say you will get? You will get 2 cos. You add the two values here, A plus B divided by 2. Then sine, you subtract A minus B divided by 2. So if I do the same here, so you can see sine x plus delta x minus sine x minus sine x. So the numerator now will become like this. So the numerator is going to be like this. We have delta y divided by delta x, which is equals to, so the numerator will now be 2 cos sine, 2 cos, open bracket, we said A, so this is A is x plus delta x plus this value here, which is x plus x, then that is that 2 cos this, then sine, open bracket, A minus B, which is x plus delta x minus x. Then don't forget this bracket, we are going to divide by 2. Divided by 2. Same thing with this. Divided by 2. Then everything divided by delta x. Take note, let me go back to the identity so that you get it very well. It says sine A minus sine B is going to be equals to 2 cos A plus B divided by 2. 2 cos this A plus this B divided by 2. Then sine this A plus this B divided by 2. So that is what I've used here. So this is my A is x plus delta x, then B is x. So I have 2 cos A plus B divided by 2, you can see it. Then sine A minus B, you can see that x plus delta x is A, B is x. So A minus B divided by 2 in bracket, then everything is already divided by delta x. So when you get this approach, what next? The next thing is, let's simplify this bracket. Since x and x, they are like terms, we are going to have 2x. So let me just copy it fast. So we are going to have something like this. So this is going to give us 2x. So this x will leave here. So 2x, then this place x minus x here, you know, is 0. They are like terms. So we are not going to have any x here. So x will leave here. Then x will leave here. So that is that. Then let's come to this place. Let's come to this place. Let me also copy this. So if we come to the next step, and do the next step here. Okay, let's do the next step here. Then you can see that 2 can go into 2. So 2 can go into 2 here. So in the next step, I'm going to get x will stand on its own. That means this 2 is leaving this place. It's only delta x that we have divided by 2. Then this 2 is leaving this place also. Understand what I just did? 2x divided by 2 is going to give us x, which is this. Then delta x divided by 2 is going to be this. So this is where we are now. Yes. Then to end up our differentiation now, what are we going to do now? Then you discover that these 2 can leave this place. It can become the denominator of this. If I make it like this, that means this 2 is leaving this place. It's just a kind of reverse process. I hope you understand what I did here. I want you to understand this place very well. If you look at what I just did here, I just brought this 2 to be the denominator of delta x. So if I reverse the process, you know that this numerator divided by delta x over 2 is the same thing as 2 times the numerator divided by delta x. It's just a reverse process. I just reverse this process. You can reverse it to this, then this you can also reverse it back to this. So both of them, they are the same. Now that we have this, I can finally conclude my first principle differentiation. All I need to do now is to group this numerator, this side, with this, and this is what I'm going to get, something like this. dy, okay, dy dx, delta y delta x equals to, we have this now, which is cos, this is cos open bracket x plus delta x divided by 2, yes, then open bracket sine delta x divided by 2, then all this one, divided by delta x okay. So this one, let me move it down so that you can see it well. So this side sine delta x over 2 divided by delta x over 2, I just group them as a single bracket like this. You can see them here. And now that they are on one side, we can now take them out. So if you remember, if you recall these identities with this, if you go to number 11, you can see this place, sine a over 2, like this half angle identity. Sine a over 2 is the same thing as plus or minus square root 1 minus cos a over 2. That means square root of 1 minus cos this numerator now, which is a, divided by 2. So if I do same thing here, so this place will now become plus, and will now become plus this square root 1 minus cos delta x over 2 divided by this. But no time to do that. We just assume now, just let this side of the expression, this very side, just make it equals to 1, which is now something like this. So we are going to have delta y divided by delta x equals to cos x plus delta x divided by 2. So this side of the equation, let's just assume it to be 1. Let's just turn it to be equals to 1. So just take this side to be 1, because the process involved in solving this down is very long. So let's just leave it. So if you take this side to be 1, then finally we can now put our limit of the differentiation now. So if you get the limit of this, which is limit delta y divided by delta x when delta x approaches 0, so what are you going to get now? So the result is now going to be equals to, so you just, every value you have here, this place is going to be 0, which is 0 divided by 2 is 0, 0 plus x is x. So it's now going to be equal to something like this. Let me just put it down so that you can see it, which is cos open bracket x plus 0 divided by 2, something like this, times 1. So you ignore the times 1, and that will give us our final result. Let me put the result up here so that we can see it clearly. Put it somewhere here. the result somewhere here. So finally, let's just put it. So finally, the y, the x will now be equals to, and see, when delta x is 0, you're now left with cos x. The y dx equals to cos x. So that is it. So this is how you differentiate sin x using first principle. You can see all the approach down. You can see the trig ratios we summarize using the applet. So just go through those trig ratios. They are very important. They will help you in your solution. Then when you get to this place, you can see the analysis we did here by bringing 2 down here. Then in this place, take this side to be equals to 1. Because the process is very long, so it will take most of our time. So just ignore it. It's 1. Then substitute delta x as 0 when the limit of delta y over delta x, substitute delta x as 0 and delta x approaches 0. So you are going to get it. So finally, the y dx equals to cos x. So that is it. So that's how we got this answer in this table. The differentiation of sin x is equals to cos x. So this is the first principle explanation of how you can differentiate sin x to get this result of the y dx is equals to cos x. But all this step I just did now, you don't really need to do it when you are in exam condition. For example, in an exam condition, they ask you to differentiate the y dx. For exam condition, if they ask you to differentiate sin x, you don't need to start solving all these first principles. It's a waste of time. Just go straight to the answer that the y dx is equals to cos x. But I just want you to know from first principle how this value end up in giving us this result. So take note of this. It's very, very important. In our next video, I'm going to do for tan, sec, cot, and cosec. The one of course is similar to this. It's the same approach, the same method. All you just need to do if you are differentiating cos from first principle is the same step. When you get to this place, it's just that the only difference is this place is going to be cos, this place is going to be cos. Then you are going to use this formula to do it, which is this. So in that case, you are going to use this one. You can see you are having minus 2 sine. You can see it. Then you do the same approach, and that is why at the end of the day, this minus 2, this 2 will go down. Then you are leaving minus sine as your result. So that's why you can see from the table, when you differentiate cos x, you are going to have minus sine x. So that is just all that from first principle. So I hope you understand all I did today. In our next video, we continue with the differentiation of trigonometric function. So that is all for now. Till our next class.